The recipient of the Engineering Medal for Management is Dr. Roderick C. Tennyson.
My name is Rod Tennyson. I'm a graduate engineer from the University of Toronto, and I went through aeronautical engineering and then a master's degree at the Aerospace Institute. And I subsequently went on to do a PhD, and then I went promptly down to NASA to do research on rocket structures. My advice for young engineers, if I could give an example first as to basis of my advice, is the Apollo 13 rescue mission that I was a member of the University of Toronto team. Back in 1970, Apollo 13 blew an oxygen tank in the service module. There's three components to the Apollo vehicle. There's the service module that provides all the power, the oxygen, etc. Then there's the command module that has the space shield on it, so the astronauts live in that and return in that. But then this mission was going to the moon, so it had a lunar module, multi-legged beast, tacked on the end. Well, when the oxygen tank blew, it destroyed the service module. So the astronauts had no access to heat, energy, water, but they did have that in the lunar module. But they were only halfway to the moon. They swung around the moon using the sun and some stars as guidance and whatever Houston could provide them. But just before the astronauts were to return, our institute got a call from Grumman Aerospace that was in charge of the lunar module, and they were having a problem. They had no idea how to separate the lunar module from the command module so they could re-enter the Earth, because it's the only one that had the temperature heat shield on. They blew away the service module because you could get rid of that. They didn't know how to discharge the lunar module because they couldn't come in with it on the back of the command module. It could tumble and they'd burn up and die. So they'd like us to give them some idea of what kind of pressure would be needed to blow the lunar module away from the command module, to separate it in time so that the command module could re-enter without burning up. My specialty was structural design. So I went away to determine how to close the latch with whatever pressure my aerodynamics guys were going to come up with to make sure it would close properly. If it stayed open or wouldn't close properly, the guys were going to die then anyway. Bottom line is, our team worked together, and around 4 o'clock that afternoon, we were told to call back and give them our answer, what pressure is needed. Now, the normal operating pressure was about 5 pounds per square inch. We came back with an answer of just over 2 pounds per square inch, was enough to blow that lunar module away and allow the guys to close the latch and re-enter. Our assumption had been all along, NASA wasn't just relying on us. They had MIT, they had Stanford, Caltech. They have all the NASA bases, brilliant scientists and engineers, but this was a real engineering problem. So the next day, we heard that the astronauts got back, so we were happy, going on about our business. About 2 weeks later, we get a call from NASA saying that, oh, by the way, guys, you were the only people we consulted. Said, thank goodness we didn't know that at the time. If someone said, you got the lives of 3 astronauts in play and you're the only guys we're going to count on, it'd be hard to come to a conclusion. You'd always be double guessing yourself. So then, on the 40th anniversary, the pilot, Fred Hayes, was coming to Toronto, and he acknowledged that we saved the astronauts' lives. There's a moral to this story that for young engineers, you're going to encounter in your careers that this may look impossible. It's probably not. And with your engineering skills and knowledge, you're going to be able to get around and solve that problem. My legacy, I hope, will be the Trans-Africa Pipeline. Trans-Africa Pipeline is a pipeline that transports water from solar-powered desalination plants, both on the Atlantic Ocean and on the other coast of Africa, the Red Sea. So we're pumping water at about 800,000 cubic meters a day, both ways, providing clean, potable water for millions of people. We're going to change the face of Africa in the next less than a decade.
For his pioneering leadership in aerospace engineering research and education, most recently bringing clean drinking water to tens of millions of people in the Sahel region of Africa, Dr. Roderick Tennyson is a deserving recipient of the Engineering Medal in the Management category.